I want to study a concept. I want to quantify it. What choice do I have to make? Danny?
Is it like a theory?
Yes. I have a theory of measurement. So what choice am I making, Jake? It's like week 2. You can't be lost already. I haven't even done any math yet. What the hell? All right. You are a researcher. You want to study something. Give me something to study. Caitlin? Huh?
Wait, what?
Give me something to study. Give me something to measure. Give me a concept that I can turn into a variable.
Like animals?
Sure. What about the animals?
I don't know.
Scaredness. Deliciousness. Softness. Pick one.
You could do like the type. Or no? Okay, softness.
Softness. Thank you.
Sorry.
All right. I'm sending her out into the world, and I'm going to tell her, give me a data set on how soft the animals are. Where do you start? What's your first animal you're going to go up rub against? A dog. Okay? So, dog. How do you measure softness? How do you quantify it? Somebody help her out. How do you quantify a concept like softness? Ben. Okay. So what makes something soft or not? How do you know if something is soft? You touch it. Okay. But I want data, right? I want a number. I want to quantify softness. I want a number next to the word dog. What are you going to do?
Scale it.
You're going to determine what scale to measure it on. Okay? What are our options? And this is where we get into the last class. So what's the most basic way to measure softness?
Soft or not.
Soft or not soft? What kind of variable is that? You can look. That's okay.
Okay.
The dichotomous variable. What's the other word for dichotomous?
Dummy.
Dummy variable. Okay? So it'll literally be softness, 1 or 0. So our dog's soft.
Yes.
Yes. What do we record that as?
Only one.
1. It has softness. Okay? So we are now creating a data set, right? A data set of snuggles. Call it. We're going to go up to an animal, we're going to snuggle with it and say whether it's soft or not. We have one way to measure dummy variables or dichotomous variables. All right. Are there other ways to measure softness other than a dummy variable?
Yes.
Yes. How else can we measure it? It's the few slides before we did dichotomous.
Ordinal.
All right. We could do an ordinal scale. Okay. What would our ordinal scale look like?
Like really soft, kind of soft.
Really soft.
Not soft.
Kind of soft. Scratchy. Oh my God, I'm going to die. Right? So we can create a 5-point scale. What's the softest animal out there in the world? A panda bear. Panda bear. What's the least softest out there?
A porcupine.
A porcupine. Okay, so now we have an objective scale from 1 to 5. Levels of softness. Okay. What if I told you there actually is a scientific measure of softness? And that there's this little pen out there that it kind of looks like a stylus that I've lost already. And you go up to something, can I have your arm? And you go like this, and it measures the softness. And it gives me a number. What kind of measurement would that be?
Nominal?
It would be more like a continuous one, right? Nominals are just categories that have no order.
Okay.
And if I told you that there was a device out there, would you believe me?
No.
No.
Already? There is. I just don't remember the name of it right now. But you can take there's like a thing, it looks like this, it has a little plunger to it, and it measures the resistance. Right? So if you skin, there's a little bit of give to it. The table is hard, there's no softness there. So trust me, don't Google it.
Can't Google it?
No Googling. not live. Yes.
Why is the continuous the best way to measure them?
Because it contains the most amount of information.
Okay.
It allows more variation. Because really what we do when we're measuring is we're trying to accurately depict the variation that exists. Here's a real world example. In, I think it's the American National Election Studies, there is a type of measurement known as a feeling thermometer. And it asks respondents on a scale of 0, which is really cold, to 100, which is really hot, what are your feelings towards, and then you insert a person's name. Okay. Now that's a 101 point scale from 0 to 100, because you got to count the 0. That's 101 different ways of categorizing your feelings towards Hillary Clinton. So we can see the difference between somebody who says, yeah, she's okay, 60, versus somebody that says, I love Hillary Clinton, oh my God, 100. There's a difference there in the amount of feeling. And by having a more continuous form of measurement, we can be more precise in how we measure. Make sense? Versus, do you like Hillary or not? Yes or no, a dummy variable. Okay. So we have had this discussion. The next step is to go out and build the Snuggles database. What are you actually going to do? How are you going to record that information? You're going out there, you're measuring the Snuggles.
Bell curve.
You're going to know. Stop trying to sound smart. Tell me what you're actually going to do.
You can write it down.
You're going to write it down?
Yeah.
What might somebody else do? How are you going to keep all this information?
Graph.
No, you're not graphing anything. You got to have data to graph. How are you going to hold your data?
Computer.
On a computer. All right.
In the wild?
We're getting... What's this?
Oh.
What is this? You know it.
A phone.
It's a phone. Can it go in the wild?
Sure.
Can you put information into it?
Yeah.
Okay.
Okay.
So you have a computer in your hand in the wild. I'll paint it yellow so it looks like it's tougher than, it's like I have an OtterBox case on it. The kind that you throw, this is not one of those, so I'm not throwing my phone. Okay? So you're going to go out in the wild and you're going to start snuggling animals. And you're going to record it, right? How are you going to do that? You open up a Word file, you're going to text it to your friend. Hey dude, bear, 0. Send. Hey mom, porcupine, -50. Ouch. Where's the nearest urgent care? Right. Pretend you're a scientist. Pretend you have a coat on if that's what you need. Pretend you've got a big ass computer. How are you going to record your information? So, all right. What we're going to talk about today is how to examine data, how you collect it, how you store it, what do you do with it. Now, I haven't taught you anything in statistics yet. All I've taught you is that when you measure something, there are ways you can measure it. But the next step when you collect data is to actually manage it and control it and have it so that you can make a graph someday. So what I want to walk you through today are some programs that you can use to manage and do statistics. I do this at the beginning of class rather than at the end because you need to sort of know that this is coming. Okay. So we're going to start in this class doing everything by hand. So you just need a calculator. Here's a pro tip. Open up the calculator on your phone and then do this. Turn it sideways. Sorry. Turn it sideways, it turns into a scientific calculator. You get more buttons. Works on Android and an iPhone. Okay. Should have gotten an outer box. All right. You don't need to go out and buy the TI-83 or 84 that plugs into your computer and has, $100 later. You don't really need to do that because this is all bucket on the floor stuff. Right? You can use your fingers and your toes and your friends' fingers and toes if you need to. But eventually, what we're going to want to get to is having the computer do all the work for us. Because remember that equation? The sum of xi minus x bar parentheses times y minus y bar over. That takes a lot of work by hand. You're going to want to let the computer do it. What's the other advantage of letting the computer do your calculations for you?
Won't screw up.
You won't screw up, and it saves it for you. Okay? So what we're going to talk about today are the options out there that will be available to you to do this work in the future once I've actually taught you how to do something. All right. So before we start playing with data, I want you to remember a couple of things. First of all, whenever you have data, you want to keep a pristine, clean version of it segregated from your working files on your computer. Because you don't want to screw something up in the programming and then make a really big mistake that you can't fix because you don't have a clean data set. I've learned this from personal experience because you'll think, oh, I'm just going to drop these observations. And you drop them and then you keep working on something and then you hit save and you realize, whoa, I just deleted a whole bunch of my data because I didn't have a clean version someplace else. So if you're working with a data set, you've gone out and you've hugged 10 snuggly animals, and before you do anything, before you make a graph, before you do anything else, you hit save as, and you file it away as snuggly clean. And you're never going to use that file unless you have an uh-oh. That's good data management practice, having clean versions of your data. The next thing you're going to do is anytime you make changes to that data, you're going to document it. So you're looking through, you're making a graph about the frequency of snuggly animals in the wild. And you realize that you had bear as, X instead of as an actual number. Well, you're going to write down recode bear and then put the appropriate value in that. And you're going to keep a log of all the changes that you've made from that original clean data set. Because you're going to want to know what it is that you've done when you've screwed up your data. So there's an accounting part of this as well. You have to sort of keep a log of the changes that you make. This is good practice, not just for this class, but when you're out in the real world and your employer gets sued and you have to meet with the lawyers and they want to know how you arrived at your conclusion, and you said, well, I analyzed some data. They're going to want to know what you did to that. And when you have a statistics professor that's been sued, he really wants you to know how to protect yourself for when someday you might be sued. Not me, my professor. Okay, and he was obsessed about this because he's like, you are making a choice when you change that clean data, and you need to be able to explain what you did. The first program I want to talk about is called R. Has anybody ever heard of R before? No? Okay. R is interesting. R is sort of the standard for statisticians. Right? So if you want to look like you really know what you're doing, you're using R. Right? This is professional level statistics programs. And I've got some links here, and I will post these links in Moodle so that you can go to these websites. But R as a program, how to describe R? Well, let me just fire it up and show it to you. This is R. When you open it, you are confronted with nothing but a blinking little cursor here. There's no buttons. There aren't a lot of drop downs. Right? There's a couple like save workspace, stop what you're doing. There's some stuff here. R by itself is just that blinking command prompt. This is not Excel, right? Right? Where am I going to put the snuggly numbers? Snuggles. Error. More snuggles. Error. If the blinking cursor doesn't scare you, it should. Because it's giving you nothing. It's not giving you a hint. It's not saying, what would you like to do first? It's just a blinking cursor that no matter what you type, you get error. So let's just say learning R can be an adventure. But fortunately, there are things out there that make R work a little bit nicer. Let's close out R. This is a little bit better. I still got the blinky thing over here, and then I type snuggles, I still get the same error. But man, there's some options over here. Right? This is known as RStudio, and RStudio is a user interface that you can download to your computer. When it starts up a version of R, so you also have to have R on your computer. But what RStudio does is it helps you understand what it is that R needs from you. RStudio is newer, it's kind of popular. There's one more out there called R Commander. There it is. Come on. There it is. That's a little bit better. That allows you to, say, edit or view a data set, right? It allows you to still got the blinking cursor there, so you still got to figure out what to type. And then down here at the bottom, it'll actually pull back the response. So again, I tell R snuggles, and I hit submit. I got an error code again, so it's not going to give me any output. So it looks really scary. Here's the great thing about R, though. It's absolutely free. We like free stuff, right? So the most professional version of the software that's out there is absolutely free. You don't have to pay anything. The other great thing about R, it can do anything except snuggles. Right? R can do anything that you ask it to do. You just have to learn how to ask. It is what the pros use. You look very snobby when you say, well, I did my analysis in R. And the only way you're going to learn how to do this is by using the R community. And there is a huge global community out there known as CRAN, the Comprehensive R Network, Archive Network. And CRAN will tell you how to do anything. It has message boards, it has setup guides. This is sort of the best of the internet, right? If the internet was designed to bring people together and reduce the influence of space, here's your shiny example. It's not all about pornography and illegal torrent downloads. Benefit to society. This is it. This is R. Manuals, frequently asked questions, all of this stuff will help you learn R. For free. That's the nice thing about R. It's what the pros use, it's free. The negatives, it's really hard. But I can promise you, you can learn R. I did at one point. Stopped using it after a while. Made me have low self-esteem. But you can learn R. It is a steep learning curve. Because R does some really weird stuff that makes sense to people that like blinking cursors and like programming language, but doesn't make sense to the average consumer that just wants to click a button and highlight something and have something happen. All right? So you have to sort of make a commitment. It's kind of like learning a new language. In fact, that's what R is. R is a language. That's where the name comes from. There's a computer program out there called S+, where people tried to make money off of R, but it was based off of the R programming language. So that's where the R version comes from. R and S, get it? Kind of similar names. So whatever you do, you might have to buy a book. One, maybe two. So 2 books, free program, free user interface, a little bit of time, some willingness to be getting errors repeatedly. But once you have it figured out, you're good to go. And you look good doing it because it's R. That's an option. Because of this steep learning curve, I'm not going to use R in class. Because I don't want to spend 3 weeks teaching you how to use R when I can be teaching you the statistics part of it. But it's out there, and if you are serious about learning statistics and going on, you might want to play with this a little bit. The very last time that I used R, I was trying to make a very specific type of graph. And I knew R could make this very specific type of graph. And that was the last time I used R, and it was 2007. And today, to teach this class, I re-downloaded R and put it on my computer, and it's the exact same. It has not changed. The only thing that has changed is the addition of those things like R Commander and R Studio, which are there to help you out. R does not care about being user-friendly. R cares about being able to do absolutely anything you ask it to do. So that's one option. The second option is called Stata, or Stata, depending upon whether you pronounce it as data or data. Stata, Stata, it's Stata. Stata is the program that I use whenever I'm using a statistical package. Okay. It looks okay. You fire it up. Okay. You're thinking, oh my God, it's a black screen with like green writing. This is DOS stuff. This is what they use in old movies. I just made it look that way because I like the way it looks. It actually comes up as a big white screen. But if I show you the big white screen, then you think, oh my God, this is just like R. And he told me that was really hard. So I make it look like this because warm and fuzzies. Okay. Now, Stata also has a command line. It's got that blinking cursor. But Stata also has drop downs. You can use Stata and use the programming language of Stata, which is very simple. Or you can use the drop downs. When I first learned Stata, they didn't have the drop downs. So you had to learn the language. You had to learn the code. You can still use the code. I typed the word edit, and it brought me a data set where I can edit. And I can now type things in and create my data set. Okay. And then when I'm done editing, I just close this. And now I've got some variables. I need to label my variables. Label 1, this will be animal. Come on. I need to work on this. Oh, unlock. There we go. Animal. And you see, it said label variable, variable 1, animal. So there's still a language there, but the drop downs convert what you're asking it to do into the Stata language. I told Stata, give me a summary of variable 2. I just typed that in. And it says, okay, variable 2 has 2 observations. The mean score is 50. The standard deviation is 70. And the minimum value is 0 and the maximum value is 100. All because I knew that there's a command that's sum, and I give it a variable name. That's the way Stata works. You learn the command name, and then you tell it the variable, and then if there's any options, you add the options. It's not a hard language to learn. I still remember this stuff from when I started using it 15 years ago. You learn it once, it's in your brain. Regression, regress x, y, done. It's not that hard. But if I did forget, I can always use the drop downs. All right, data. Let's describe our data. Summary statistics. I want to know variable, again, just variable 2. Yes, okay. And now using the drop downs, I get the exact same information. So this is Stata. Let's talk about the good and the bad. The good. Many people use it. So because many people use it, what should we find? There's a user community out there. UCLA has a great user community. They've done lots of things with Stata, and they host it on their website. So lots of times when I have a Stata question, I go right to this UCLA computing website. Lots of people use it, which means also that books are written for it. So I have books in my office that are helpful. Beginning statistics books have Stata built into it. It also has a really good graphics editor. So if I want to create a graph, I can use the drop downs, and it'll give me the graph that I ask for. But then if I want to change things, like I want to make that line blue. I literally just click on the line and it brings up a whole host of properties and I can tell it blue and it'll change it to blue. And when we get to doing things like making frequency distributions or scatter plots, when I do it in class, I'll probably use Stata as demo it to show you what it is that we're trying to build, because making graphs and figures in Stata is really easy. Here's the negative. It costs money. You as a student can go ahead and buy a light version of Stata for students, and it'll run you about 90 bucks. They actually have semester by semester rentals, so I had to decide if I wanted you guys to pay 35 bucks to rent Stata for 6 months, kind of like a textbook. I decided not to do that. You could buy a forever, I own this and it will do anything I ask version for $400, which is a lot. But if you use it for the rest of your life, it's not that much money. But again, 90 bucks, 400 bucks. The other negative to it is that you're relying a lot on the drop downs, so you still kind of have to use a coding language if you want to get really fine-tuned. It's an option. You might still have to learn something. It is nowhere as near hard as R is. But it's still what Stata runs off of, a computing coding language. Third option, probably the most popular option, the one you already have on your computers. It's called SPSS. It's owned by IBM. It's a business software package. It is designed for companies to use. It is not necessarily designed for academics. It is designed for people in financial services, data analysis, that sort of stuff. All right? I mean, my God, IBM owns it now. It essentially, when you fire it up, and you all can on your computers, it's under IBM SPSS 24. When you fire it up, it looks a little friendlier than Stata. I'm going to turn mine on, and then I'm going to be told that I have a license issue because I haven't updated it in a long time. But I'll at least fire it up. Little splash screen. Here we go. Very user-friendly. Gives you a nice little pop-up window. What do you want to do? Do you want to do a new file? You want to open a recent file? Do you want to do some tutorials? Right? Gives you a little news update. What do you want to do? Let's see if it'll let me do a new file. And here's the error. I don't have a license. No. No, I don't want to buy it. Leave me alone. Let's see what this looks like. All right. So it finally opens, and here's SPSS. And why does this look so soft and kind and cuddly? Because it looks like Excel. Right? There's no blinking sort of, what do you want to do? Where's your command prompt? What do you want to do? Right? It looks like Excel. There would be more options up here, but my license is expired. But it has the drop downs like Stata does, like data management and those sorts of things. So it looks like Excel. I've seen this before. It's got drop downs. If you want to use the coding language, it's really hard to use. Like it really doesn't want you to do anything but click on things and use drop down menus. Right? There is a way to get at the coding language that SPSS uses, the syntax, but they don't want you to do that. They want you to just click on what you need and get your result. And this is why this is so friendly. Right? It essentially is Excel with steroids. Right? It's Excel on some performing enhancing drugs. But it's comfortable. It's not going to stress you out. There's no blinking cursor there that's saying, do something already. There's no error codes that pop up. When they do, they run it as a little polite little output. You might want to check your license. It appears to be expired. Okay. This is what we'll use in class, because this is soft and cuddly, and I've seen this before. It's cool. The other reason we'll use it in class, the university has a site license for it. So if you're on campus, I'm not saying every computer has it installed. I know every computer here has it installed, and I know in some of the other labs on campus they have it installed. You can go ahead and use it. There is a free trial. If at some point you don't want to come to campus and use the campus version, you can download a free trial for your desktop. But I think it's a really short trial. It's only like a month. So save that for the end of the class when you're working on your term papers. See, it's so nice. Like, are you sure you want to proceed? Yes. Go away. So the positives, university license, soft and fuzzy. Negatives, it really isn't that much better than Excel. It is an entry-level statistics program. There are things it cannot do, and there are also things that it does incorrectly. And the last part, it costs so much for an individual license. I went to look it up this morning. How much would it cost for a student to buy SPSS? It gave me financing options. I don't need a second mortgage. I just need something to do the calculations for me. Right? I really don't need financing options. That should scare you. Last program. No. No, you are not going to use Excel to do any data analysis in my class over my dead body, which some of you have the ability to do, but no. And I'm going to make this point because other departments on this campus use Excel to teach people statistics. No, it's wrong. I'm not going to do it. The only thing you're allowed Excel to do in Excel is to build a table, right? It's to put Panda and 100. You're only allowed to build a data set in Excel because it's everywhere. It's on your damn phone. It's on the laptop you just bought. Right? It's like the default data program out there. No. Not allowed to do it. I'll smack you in the nose with a newspaper. If you turn in a paper that has an Excel graph in it, I'm going to smack you in the nose. I'm going to roll up your paper and just, no. No. It's a high school move. All right? We're not in high school anymore. No Excel. You can only use it to create your database. Why? Because it has that table function. You open it up. Nothing else. No. And if you do it, you're dead to me. I can't even turn in a grade for you because your existence did not happen. Aaron who? Never met Aaron Martin in my life. Nope. I do not know her. I have very strong feelings about this in case you haven't picked that up. Right? It's only really, again, to replace paper. Because you're in the field and you don't want to carry a notebook because you're trying to hug a bear. Right? And you use your phone and you create an Excel spreadsheet. That's fine. But you will not do anything with like an equal sign. You will not add numbers in Excel. You will not create an average in Excel. There will be no Excel language being used. Ever. So, what can you do in this class? Like I said, you'll have SPSS. And when I demo things in class after I get my license fixed, we'll all be using the same SPSS. Right? It's the one that's most available to you on campus. But if you're that person that likes to play with things, that likes to do extra readings, that might take another statistics class, you need to spend just a little bit of time with R. Because you go on the job market and you have R experience, that's an actual tool. Somebody has told students that they should put on their resume like skills that they have, and they put things down like Microsoft Office. No shit. Everybody can use Microsoft Office. And if you can't, there's no way in hell I'm going to hire you. Internet Explorer. I've actually seen that on a resume. Shut up. I don't even think Internet Explorer is a program anymore. Right? So whatever class they have told you in preparing your resume to put things like that on there, they're wrong. But if you have something on your resume that says, yes, I'm familiar with R and Stata and SPSS, well, now I know you're for real, because you know that R exists. R is popular because you can do anything in it. Companies like it because it's free, and it's what professionals use. You walk into some meeting and you throw up an Excel chart, you might as well just take all your clothes off, because they're going to be talking about you anyways. So to go ahead and do something crazy. All right? Take all your clothes off and poop on the floor. Because that's about how crazy you just were. Look at my Excel graph. Excuse me, I have to go to the bathroom now, in front of all of you. I had a professor once who was so passionate about this. He was one of those guys that's so convincing about things that he actually takes it that step too far. And so he was telling us about how he was once asked to review an article for a journal submission that had an Excel table in it. And he's like, I didn't even read the article. It's like, whoa. That's kind of a jerk move. Like, you didn't even consider what the person had to say. It's like, I saw a table made by Excel. I didn't even read it. Like, wow. Okay. That's how strongly you feel about it, fine. And then the guy I'm sitting next to, who is a tenured professor at a large state school, goes, what a jerk. I use Excel all the time. Don't send anything to him. Okay. One of the goals in this class is to give you a skill that you can use. Right? This isn't just some fluff class, and try not to insult any of my colleagues here by pointing to their classes, but we can all agree, let's do PALS. Can we all agree that PALS is kind of a fluff class? There's a class called fitness walking where you walk around a track. Right. You go on somebody's transcript and you see PALS 109 fitness walking, you know they didn't learn anything. They just earned credit. But if you see on somebody's transcript introductory statistics for political and social scientists, you're like, hey, they might have learned something. So if I'm going to go as far as to teach you how to do this stuff, this is a skill you have acquired. When you go to get a job, you will want to say, this is a skill I have. Are you going to put fitness walking on your resume? I know how to walk in a circle with the appropriate technique, and I have endurance because I can do it 4 times in a 50-minute class period. Or are you going to say, yeah, I took intro stats, and I learned how to use R and a little bit of SPSS. What do you think is more valuable to you in your future potential and careers? All right. So that's why we're doing this.